Okay, so it's a new day and mixing this. Okay, wait. Okay, so it's a new day and what's happening? I don't know. Okay, there was some issue with my headphones. The speak to chat was activated, and whenever I was trying to speak something, it got triggered. And where's this one? 392.70. No, that should be a scratch. I will correct it later. Okay, so today is a new day, and it's day 39 of daily code log, and I'm going to change the strategy a bit to bump up my training. Also, I have noticed that I'm solving very less problems, currently just one problem that's going on the easy side, so decided to strictly solve 3 or more problems every day. It may need there be times that I need to watch solution frequently, but that will be on the learning side. Okay, and it's better to solve more and see editorial than not solving. Yeah, so okay, so here's the rule. I will try and iterate for around 50 minutes. I will start a timer, and if I don't get through it in the next 10 minutes, I'm going to see the hints and try to iterate on it, not more than 1 or 30 minutes on each problem. Okay, and that will mark, and I will solve 1100, next 1200, and next a 1300 problem in the sequence. Great. Okay, without wasting any more time, let's get to our first problem. Okay, great. Let's start. I'm starting the timer. Um, there will be a 50-minute timer. Okay, it will ring once I exhaust it. It has started. Let's go. You're given n binary piles. Okay, ith of which consists ai zeros on the top and bi ones on the bottom. So ones will be on the lower side. Okay. In one operation, you can take the top element of any pile and move it to any position in the pile. Great. Okay. Including the pile it was taken from. Top element of any pile. Take the top element of any pile. Okay, any pile and move it to any position in any pile. कहीं भी कोई भी pile में move किया जा सकता है, but top element move just are selectable, including the pile it was taken off from. Okay. अपने खुद के pile में भी anyway position. Calculate the minimum number of operations required to make it so that the ith pile consists ci zeros and the top and di ones at the bottom. Okay. C है मेरे पास test case and bi and we want to make it ci and di, right? Okay. We have n. Okay. We have n piles. Okay. got it. All right. I have 1 3 1 2. We have two piles, 1 1 1 2. So the first pile was initially this, second first pile was initially this, and you want both the piles to be 1 2 1 2, right? The minimum number of operations required to achieve the target state. Okay, so I think we need to add in one integer where it will be the sum of the total operations, right? So if I have something like 1 0 and 3 1s, then 1 0 and 1 1, invariant, need to find invariant, but is not changing after doing any operation. So we take the 0 from here and move it to here. Pile 1, pile 2, zeros and ones, zeros and ones. So pile 1 had 1 0 3 1 1 1. Now remove 1 0 and we add the 2 0 to the bottom. Make sense? You can put here, एक 1 को टॉप में ला सकते हैं तो खुद में ही डाल देते हैं 1 3 1 1. नेक्स्ट ऑपरेशन में 1 उठाते हैं और बॉटम में घुसा देते हैं. नेक्स्ट ऑपरेशन 1 2 करते हैं, 1 2 कर देते हैं. तो ये ओरिजिनल स्टेट था. दिस वाज नथिंग. 1 operation, 2 operation. In 2 operation you can do it. Yeah. Basically what we are doing is खुद का 0 और 1 जो भी है it can be reconfigured. Extra जो है it can stay in the file. Just one extra 1 को मूव करना है and it can be moved by just ऊपर का एलिमेंट बीच में लाके रख देंगे. डिपेंड करता है कि ये 1 कितना नीचे है, कितना एलिमेंट्स ऊपर से क्लीन करना होगा. The giver will ultimately fulfill the needy ones. ठीक है. So there are two types, which has access and which needs. ठीक है. So a file will have access, then just the difference between first one and इसको सरफेस पे लाना होगा and +1 to make the adjustments. अरे कितना है, right? कितना सारे एलिमेंट्स है. इसके ऊपर कितना जीरोस है ये डिपेंड करता है. 1 0 है. काउंट ऑफ zeros to remove for balancing 1, है ना. वही है कि ओवर से जीरोस हटाओ, अंदर अपने में ही ले लो या तो उधर शिफ्ट कर दो, डजंट मैटर. ठीक है. जीरोस चाहिए जिसको एक्सेस डायरेक्टली इट कैन शिफ्ट द zeros, right? So 2 cases. एक्चुअली 4 केसेस है. Case 1, both have sufficient, then 0 operations. Case 2, now here 2 file था. I can have many 1000 files, right? So how do we go about that? तो जैसे हम लोग मूव कर रहे हैं, okay, everybody registers their demand, right? तो जिसको चाहिए एक्स्ट्रा फाइल एक होगा, ये होगा. So the total operation from surfacing to moving will be जितना zeros है उसको नीचे लेके आना होगा, एंड फिर जितना ones है जो needed है, तो ऊपर में top zeros plus required one, ये हुआ cost. अच्छा, ये cost है. Case 2 can be any need zeros. I need zeros. जिसको zeros चाहिए can be easily achieved through same number of operations from other files. So need zeros. अच्छा, अगर मान लो 0 ले लेके उसका फाइल खत्म हो गया, ones are directly exposed, ठीक है. सारे ऑपरेशंस में आइटरेट करना होगा, बट ऑन एवरी ऑपरेशन आई नीड ए n log n, right? n and a log n, right? कांस्टेंट टाइम में भी कर सकते हैं, बट रीडिंग विल बी अनदर स्टफ. log n is what we can do is कि iterate through every element and see ऐसा है क्या कि टोटल एक्सेस जीरोस में आ जाता है कि 0 is stable. We cannot remove zeros here. किसी को ones चाहिए, तो there will be people who need ones and who will need zeros. zeros चाहिए तो यहाँ से दे सकते हैं, बस एक्सेस राइट, जिसका ज़्यादा है there is zeros, not at the cost of they themselves losing. So okay, if someone has extra zeros, they will have to shift it. Cost is necessary operation. Now एक्स्ट्रा जीरोस है तो वो ऐड होगा ही, किसी ना किसी को तो जाएगा ही. अब एक्स्ट्रा वंस है किसी के पास, दैट ऑल्सो विल नीड टू गो टू समवेयर राइट, नहीं तो वो उसे नहीं रख सकता. तो एक्स्ट्रा वन है तो इट जस्ट इज देखेंगे कि एक्स्ट्रा जीरोस है नहीं, तो जितना भी जीरोस है उसका कॉस्ट नेसेसरी जीरोस प्लस नंबर ऑफ वंस टू एक्स्ट्रा वंस, जस्ट हो गया. आई थिंक आई एम डन, क्योंकि जीरोस तो हटेगा ही हटेगा, दैट वोंट बी एडेड टू कॉस्ट, बट जितना जीरोस है इसको ज़रूरत है, दैट इज़ द नेसेसरी थिंग, एंड जितना वंस एक्स्ट्रा है वो हटाना है, दैट इज़ नेसेसरी. और बाकी सब जो भी एक्स्ट्रा हट रहा है वो विल बी एडजस्टेड टू समथिंग और अदर नीडी ones. So we don't want the needy ones, we want the rich ones that have the extra things, right? Okay, great. So we iterate through this principle on the 2022 and 011 01100 for the ones who have extra zero है. This is also a needy one, it has extra, right? So this will that is satiate the needs. One तो ठीक है. Now extra cost is this thing. Now it needs 0 zeros plus 1. तो ये दो ऑपरेशन इसमें लगेगा. See this one, okay, ये भी this also had extra, no needy, same here it had extra, and this was, so if okay पहले पेज में 2022 0110 1100, तो ठीक है. 2022. नाउ इसका नीड क्या है, 2 है 0, ओके, डजंट नीड एनी 0, नीड्स टू 1, नीडी है. We don't care about needy ones. 0 1, okay, needy 1 0 extra है इसके पास, 1010 extra. Now we calculate the cost from the extra ones, rich ones. So so 1 है इसके पास, right? What is extra? It has an extra 1 that it doesn't need, right? It needs at least 1 0 currently, min लेंगे, C1 need have, इस वन को एक्सेस करने के लिए तो min ले लिए, that is 0 plus removal plus ones, it is 1, def need 1 minus have 1, जो भी है। यहाँ एक ऑपरेशन बन रहा है और इसमें 2 ऑपरेशन बन रहा है। जीरोज में min ऑफ A1 C1 में 0 बनेगा और ये दोनों में डिफरेंस have 1 0 1 1, एक्स्ट्रा 0 है तो कॉस्ट तो 1 होगा, हटाना होगा, और 1 को शिफ्ट करने के लिए ये 1 है, ये 0 के लिए कॉस्ट है, ठीक है। I need a 0 and have extra 1. Needing a 0 is नहीं देखना होगा। I think you have extra, it has cost. तो 3, ठीक है, okay. Let's move to coding this one. Do I need to prove it? Because anything that has extra, it has to pay in terms of operation to get it removed, and it will be dumped to anyone that is needy. And so the needy one don't care, because the ones they having the extra, they need to, off their load, right? So let's write the pseudocode here. How do I iterate करेंगे input, ठीक है। input में रहेगा n, फिर while n minus minus we will take inputs of a, b, c, d. Now we have taken the input of a, b, c, d. उसके बाद ए बी सी डी है, 5 मिनट, आई हैव ए बी सी डी, राइट। तो व्हाट आई नीड टू डू, चलो चेक करते हैं, आइटरेट करते हैं। कॉस्ट एवरीथिंग, if a and c, so if you have more than you require, like if a is more than c, add to cost. If b is more than d, add to cost, right? दोनों if होगा। Now if a is more than c, just add the difference to the cost plus equals to whatever extra you have, a minus c, right? A is 5, c 2, 3 is extra cost. Chalo, get it removed. Now if b is more than d, if b is more than d, then what do you do? Like you have extra ones, so you take the charge of removing the top zeros. So top removal equals to minimum of whatever a comma c. Okay, and then cost plus equals to this top removal plus whatever you have, that is b minus d. Simple. Okay. Let's move to coding. Okay. This is something I learned new yesterday. It's called the principle of inclusion and exclusion. That was great. Okay. Okay, we have taken the inputs. If A is more than C, do this. If B is more than D, do this. Okay. Now there's a total cost. Okay. Now, if it's more, then you do cost plus equals to E minus C, right? And T removal equals to top removal equals to minimum of A comma C, and cost plus equals to this T removal plus B minus D, right? Now, after all the iteration, just see out the cost. This will be the min cost. Let's take the inputs and verify our facts. Minimum of A comma C means have and want. See, you have something and you want something. So if you have less or want less, that's my benefit. Have less, remove the one first, right? Great. Hello, let's submit it. Okay. But why is it in the queue? Oh, running on test 5. This is basically big O of n. We're just doing maths. It's running on test 10. Okay, I have not shared the screen, right? It's running on test 10. Running on test 14. So this question took me around it's 19, 38 2 months prior, 23, around 23, and started in 50, and 40, and 30, and 7. Wow, that's a good thing. That's a good thing. Great, it got accepted. Okay. It took me around 27 minutes. That was great. Okay, I will be back in a while. Just a 10 minutes break, and we'll continue. I am back. Let's move to the next problem. Let's start the next timer. 50 minutes. Okay, timer started. Now to the next problem. This is a 1200 rated problem, right? Okay. So Hannah and Henry are going to host a party for n people, including themselves. They bought a honey cake of size. This is the dimension 3D with height and depth, whatever, and inches for the party, and want to split it in unequal pieces. Okay. The honey cake can be cut parallelly to any of its face, like cubes में बनाया जा सकता. Okay. No diagonal cuts. To make cuts precise, each edge of length W is cut into same number of parts, and each having integer length. Similarly to for the edges. Okay, छोटा छोटा pieces किया गया है. Okay. So given the dimension of the honey cake, determine whether is it possible to cut it into n equal pieces, and if so, how? If so, how? Okay. Dimension दिया हुआ है. The dimension of one honey cake is this. It's a big number, maths. And the second line contains an integer n. इतना number of cakes में उसको pieces में काटना है. There has been no talking about t. So we need to comment t. Okay. Only one test case, right? Okay. 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 Output 3 integers w, h, c of the cake of the small cut piece. The number of cuts to be made along each of the dimension w, h, and d respectively. If it's possible to cut a cake. Okay. For a single digit manner, otherwise note that making 0 cuts along a dimension is allowed too. Okay. We have 10, 20, and 6 pieces dimensions, and we want 40 pieces. So what are the restrictions here? We can cut max okay, the restriction is 10 cuts करा सकते हैं, 20 if we do these number of cuts. So it will have a dimension of 10 cuts. One, say we have a 2, 4, and 6, right? Width is 2 and height is 4. And depth is 6. Okay. Okay. Now, what is the dimension of each? So, this piece is of height 4. This 2 means 1 1 1 1 1 1 and 6 means 1, right? This will give me a cube of 1 into 1 into 1. Okay, great. Now every cake can be cut into 20 into 40 into 6. 20 into 48,000 pieces. This will give me around 48,000 pieces, right? So 4,800 pieces of 1 sizes. Okay, great. Now we want to reduce that number to 40. Okay, so 4 3 1. If we want 40 pieces, that is the 40 pieces. अगर मेरे पास 40 pieces है, तो what I can do is I can know volume of one single piece, right? So it will be 10 into 20 into 6, that is 1200 pieces. Okay, it was initial 1200 pieces. Now I want 40 pieces because each cube is of 30 cc, cubic centimeter, right? If we take centimeter as the default unit measurement. Okay, great. Now 30. So how we can make 30? How we can make 30, right? So ten can be divided by we want 30 and we want the division of this 30, right? We want 40 pieces. 30 cubic centimeter, right? So 30 can be done in 10 into 3 into 1, or 5 into 6 into 1, or they can be a lot of multiples, right? What is the restricting factor here? Restricting factor is divisibility the thing by a whole number. So if we say 1 is great, something has to be divided by 1. Now something can be divided by 3, that is 6. and something has to give me 3, right? So this can be divided into 2 and it will give me 3. Something has to give me 10. 10 can stay 1. So 2, 2, 1. This works. 10 is 1. 20 side can be divided into 2 pieces. That will give 10 each. Okay. 10 to 10 can be divided into 10 pieces. It will give me 1. 20 can be divided into 2 pieces. It could be 10. And 6 can be divided into 2 pieces. It will be. That works, but it is difficult to know what will be accurate division, right? We will have 30. Now, what we can do is we can see 30 when divided by 10. Let the smallest of them divide. Six made 0 cuts. Now there are 5 and 1. So we want 1 centimeter pieces and we want 5 centimeter pieces. We can do 2 cuts here and 20 cuts. Because if we want a big cake, say the number that comes up is not divisible by anything, right? Say we divide it by 20. It won't be divided, so don't. 10, okay. So 0. You're left with 3 into 1. That means anyone has to do 20 pieces and one has to do 3. So can anyone is divisible by 3? Is anyone divisible by 3? 20. No. 6 by 2. Yes, 2. And yeah, this can also be the size 10, 1 and 3. 30. Maybe sometimes nothing is divisible. Then what is the mathematical proof? Proof is this is a cube, right? It will have certain dimensions that are whole numbers, right? That is basically joining some smaller cubes, right? So it's basically smaller cubes combined in a certain way that doesn't break dimensions, right? So just we just check and get it's possible, and some or the other will be always divisible. Okay. Okay. Now let's code it up then. We have width, height, and depth. Okay. Now what you do is length PC per volume. No. Base volume. That is into page into D, right, divided by certain numbers that won't divide this, right? So if, it's divided by another number, right? And 10, right? Not possible because not divisible. Or we can do something, right? If it's not divisible, just check this, no? E volume. Total wall equals to. I'm doing it more weird way. Now base volume is here. Now we check vector and dimensions होगा ये and इसका size होगा 3 default value 0 से भरा होगा, right? Okay, W D H W H D, right? Okay. If say W is base for mod W वैल्यू 0। इसका मतलब कि बेस बॉल डिवाइड करता है। There can be 3 or 4 combinations, right? One has to divide it completely. इसे पूरा section ले सकते हैं. Say what is the condition where it will fail? So I have a volume of 30 and say you're dividing it by 10 or you're dividing it by 6, maybe 3. You're getting 10. And the rest of the dimensions are 7 and 3, 3, 3, 3, and you want 27 and 9 or ठीक है 9 तो 3 cakes बनेगा divided by 3, then you have 1. Okay, nine cakes. 9 cakes means 3, 3, right? Divided by 3 is divisible. That's 0. That means one side is completely 3. Now you're left with 3. Okay, I'm very complete with 3. Let's see if it works. Baseball W. Okay, so it won't need any cuts. Okay, now we can do this thing. Checks. You can do the same check with W, H, and D. You'll be returning early, then we don't need to push anything to the vector because that will be 0 cuts. Now if a base volume will be reduced, right? Base volume will be reduced. Base vol divide equals to W has been reduced. Now if base volume is divisible by any chance H, then do something else if it's divisible by else if base vol is divisible by D any chance. Then do something. Now if base volume is divisible by H, we take complete pieces of 0 cuts. 0 by 8. If it is divisible by 8, then do the same thing. And the dimension of h is 1. And one more condition, the remaining base volume if if this will be a smaller number, and this number is, that is, it can be 1. So you are talking about 9. Okay, 9 is the number of segments, and we wanted 3. 3 is the base volume. Now 3 is here. 3 divided by 3 is, yeah, it's possible. So we do 1 is divided by 3, and the meaning is 1. Now if whatever remaining is, can 1 be divided by 3? Yeah, 1 0. 1 cannot be divided. दोनों को 1 1 कर देना. I'm trying to do a lot of if else, right? What a number that got this and that. It's a pretty small. If you do it recursively, it will be pretty small, right? Try this and all the factors of this and 1 1 1. Try with 1 but is there a short way of getting the number? You want the base volume to be 30. You want the base volume to be 30. Another volume. Now, how do we make sure that this volume is achievable, right? We can see that 40 volume of 30 can be achieved in 1 into 1 into 30, 1 into 2 into 15, 1 into 3 to 10. A lot of combinations can be made, man. A lot of. Doesn't matter what order element is chosen, but the final product is the same, right? Seems pretty easy, but there is this 30 that we want to bisect in. We can iterate one by one. How does multiplying with something affect the binary system? Like we have this 1 0, we multiply it with 1 0 and it becomes 4. Shifts, right? Say if we multiply this thing with 5, then we get 15. Let me see some tutorial prints maybe. Alphabet city, model of arrays, cacti, doorway, E, F, G, H. GCD. So LCM अगर 30 है, okay. Yeah, I couldn't do this one. Oh, I was actually seeing the solution, and this is what I found out. And certainly I was doing wrong. Yeah, I was thinking correct that we'll need some kind of division tool, but this was not the correct way. W r equals to GCD of W N W and divide equals to W. Height of the part equals to GCD of remaining and the height. Depth of the part equals to And for the dimensions here, so that's something. Yeah. 10 is divided into 9 parts. नाइन कट्स, एक एक सेंटीमीटर का एक ब्लॉक मिलेगा. When he is given 3 cuts, yeah. 0 cuts means एक साइड 6 सेंटीमीटर का होगा. Okay. 10 cuts means I think sort भी करना होगा. थ्री कट्स 20 में 3 कट्स कैसे लगाए? 20 में 3 कट्स नहीं लगा सकते. You start with the largest number, right? I think ये largest to smallest कितना होगा, नहीं तो this won't work. Say we take 9 cuts and 8 centimeter. 1 centimeter का हो गया, 6 centimeter हो गया. Now we want a 5 centimeter thin. ठीक है, from 20. It should be 6. 4 cuts होना चाहिए ना 20 में. एक कट होगा, 2 कट यहाँ होगा, तो 2 मिल जाएगा. करेंगे 4 मिल जाएगा. करेक्ट है. 3 कट होगा. 3 कट मीन 4 सेक्शन. This thing is clever, man. This thing I couldn't have figured it out. Let's submit it. This is something which I didn't do, so all credits to the solution. I have to strengthen this part of the solution. Problem solving. Whatever it stacks where. I think it's most probably maths. Yeah, accept it, definitely. Okay. This was also done under 50 minutes. Let's see if we can do this thing. Okay, let's give this ICPC thing and get a different one. And these have a difficulty level of their own. Maximum distance to put, it seems cool. Is this a graph? Oh. This is also nice. One. As I'm studying now and still want to get coding these. Yeah, this one seems good. Okay, we'll be doing this one. Yes, the timer has officially started. 50 minutes. Let's think on this. You are given two integers. Hello. Case maybe the operation. Okay. You are given n and k. Size of q and r, and k is the upper limit for x and y. We have been given q and we have been given r. It is to split one integer. The maximum number of operations that you can perform on the given array. Okay. Max ups. Okay. One hour 46 minutes. What is the operation? You can perform the following operation any number of times, possibly 0. Choose two integers x and y such that y is less than x and both are less than k. There exists an index I such that in q lower bound lower Whoa, this is a maths heavy one. Remove qi from there an RJ from there. If there are multiple occurrences of QI in there. If one occurrence is removed, okay. Okay. बोला जा रहा है कि okay. They are saying that number of times you can perform this operation, right? X and Y is flowed down. That means it can be exactly divisible and can present a number or can be, it can be within the range of Y. This is the quotient, right? So Y into QI plus X can be in this range, plus 0 to I minus 1. And X mod Y RJ के बराबर होना चाहिए. तो जो एक्स्ट्रा है, okay, this is the mod part. So RJ can be from 0 to Y minus 1, right? Now what we can do is we just want to serially remove stuff and empty the array probably, right? Maximum number of operations can be size of the array n. Min operation can be 0. We cannot remove anything. Now to remove stuff we would need that where do I get Y from? Anything. It can be anything. Okay. It can be anything, right? So you can choose a random number and just okay. So this is the correlation. So let's say we have a number. Y will be larger than that. सबसे पहले we choose a number in Q. Okay. Okay, we choose a number in Q. You can have anything here. Let's say this is 1. Okay, so this has to be 0, right? Okay, then 1 into Q1, then R has to be 0, right? So X sorted in, the X will be equal to Q1. In this case, if Y is 1, then X is equal to Q1. And the Q1 can be removed with zeros. तो जितना भी 0 है उतना सारा Q1 हटा सकते हैं, right? Okay, so R doesn't have any zeros. Okay, this plan is flopped. Now, if we have q1, random remainder like say q1 is 15 and remainder is 7, then we can choose y to be something that is larger than say 8. Now x has to be this thing. So first, x is the quotient, we don't make. X is the final product. So say we know q1, then we know the ratio between them, right? We also know that anything smaller than y can fit here, right? Like any number that is smaller than y can be removed from R. Okay, anything nahi, but जो भी mod star जो भी, this is fixed, right? But these two are not fixed. So say we have a number that is थोड़ा सा big and y is, so remainder can be anything. Defload है, ठीक है, q is flowed, that means कि पता नहीं चलेगा. Anything from 0 to y minus 1 can be removed from R. ठीक है. So what is the limit of this thing and what is the limit of x? So we can remove anything from 1 to y minus 1 in R, right? So then how should we decide x and y? X can be anything that is multiple of q. Y has to be smaller than x. Yeah, that I know. So and k is given. K is given, so you have to choose numbers below k. Okay, below k. So yeah, k भी ले सकते हैं. If you take k and you divide it by q, you will get y. But what will be a good x? A good x will be something that See, we will have a lot of options in the R department, like 27. I'm going to remove this thing. Okay. We want to remove 27 and 1. So y should be more than 27, right? So 28. Okay. Now, and x has to be more than 28. And we want 1 as a quotient. So what does x divide? We have a 28 there. Mm-hmm. Twenty-eight plus 27. Possible. Remove. This will be around 15 or 55 divided by 28. We will get a remainder of 27. Remainder 1. Done. Okay. This is the protocol then. What we do is what we do, we take a remainder, pump it by 1. Like we have here 7, 717 and 565. Now we have a remainder like anything 7. Bump it by 1, that is 8. Now we want it to be less than 10. Now we want to add 8 into 5 plus 7. 47. 47 when divided by 8. Then 8 5s are 40 and remainder is 7. This can be removed. This matches. We remove it, right? Sort it in increasing or decreasing order. Or sort it in increasing order. Smallest first. Not possible. Not possible. Then we do. We have a pointer here. Not possible. 6. Not possible. You can try with 6 by 2. This is 2. Now 2 plus 1 by 2 and 2 into zero ऑपरेशन. हाँ, कम से कम 11 चाहिए यार. Not possible. ये स्मॉलेस्ट और ये भी स्मॉलेस्ट, तो दोनों स्मॉलेस्ट चाहिए, फिर भी 11 चाहिए. Not possible. Smallest में अगर we have room, then we can fit larger numbers, right? In this one, we have 5, 4, 2, 2, 1, and 800. चलो सॉर्ट कर देते हैं सब छोटे में. Now, what is the limit? Is 42. ये है तो 9 होगा. 9 into 1 plus 8. That is basically ये हो रहा है 8 plus 1 into 1 plus 8. इधर लेके आते हैं. Separate. 17 is below gone. Now 9 9 into 2 plus 8. 18 plus 8 is acceptable, gone. You can have the larger number reading. हर एक n के लिए if we do a search of binary search takes log n, then it's a binary search on values. If you search and remove, and log n will pass. Okay, I have a idea. I think it's going to work. We have to write binary search for it. Okay, let's move to coding. A vector that's named same size. Done. Sort both of them. And the smallest remainders first, right? Remainders decide what's y, and largest are going to not pass. We can skip sorting R. You can just iterate through all of the elements and see if it's possible to get a good number. Alright. Now we need to do binary search, right? For we are iterating or R. Okay. How do we manage removal of elements? So we can do is just add a check if it's taken or available. You can have an array that's that will tell about taken if it's anything is taken. Q is taken. Well, -1 and all 0 if it's 1 then it's taken. Now first go and we have x as the remainder, so int num is x plus 1 here. Now we are forming right. Now we apply this formula to create get a basically we have this set as y, right? this is my y, and this is not x. We are trying to create x, so num से that's num. So just we have got a y. Now we're trying to create x. Now to create x, we will need a valid multiplier for this y. So we're trying to find a y that is okay. I need to write a binary search for it. So binary search is function get y. Now I almost forgot how to do it. So what we will be passing here is y. We will be passing here y. Just the num. We'll be passing here the num. Then the vector to search. Vector search, right? वेक्टर का नाम है q. Okay. And I want the index, right? Want the index. We are searching on the elements, then low will be 0, high will be in -1. Makes sense. Now I want the index, and I will just mark it, right? Now, okay, mid is a q. Mid is a q. Mid candidate q, right? Okay. If this mid thing, mid is an index candidate q, index. If so we are seeing this as a, so we'll try to find out x, okay, equals to num plus 1 into q mid, okay, if this thing, this is x, okay. If x is less than equal to k, which we need to capture it less than equal to k. Y will be obviously less than k. We can skip. X तो क्योंकि y या k तो x तो उससे बड़ा होगा, k को skip कर जाएगा, okay. If it's less, then it's a valid number. We are going to find a bigger number. So low equals to mid plus 1, right? Else high equals to mid minus 1. Once this thing is done, return what? What do I return? Which index? Which index? Low or high? Just we can iterate on a small value, this one, okay. Chalo, we have 9898100, and we have, so 54221, or Q is sorted, so we want 12245. Now for 9, I want you to search that begins from the middle, that is 0 1 2 3 4, 4 plus 0 by 2, that is 2, 0 1 2. We have mid as 2. Now 9 plus 1, that is 10, into 2 plus 9, that will be 29. If 29 is less than k, that is 42, then increase the low to mid plus 1, that is great. So my low is now at 3, index 3. Now again, now I calculate the mid. Mid is low plus high by 2. 3 plus 4, 7 by 2 is 3.53. Okay. Now x is 10. num is m plus 1 is 10 into 3 into actually 4, it is 4 and plus 9. 49 is not going to cut it, so we are going to move high to something which is back of mid, and we are going to return high here. Okay, great. Okay, this will return to index 2. Okay, it will give us the index, and here we need to check vector int and taken, right? If something is taken, then what do we do? Do we skip it? What we can do of elements that are not present? If something is not present, और आगे बढ़ना है, राइट? ब्लू के पीछे वाला इंडेक्स नहीं काम करेगा. This works on a clean array. If something is taken, we just erase it from the array. I searched a bit. The standard binary search won't work because we need frequent removals from the between. Okay. Standard binary search won't cut it because we need and removals, and binary search needs static sorted, right? Array. Thinking to use set multi-set with upper bound and lower bound functions, right? Okay. Function, okay. So what you can do is write it on a set. Basically they are ordered. You'll try to find bigger and bigger numbers and just delete the one that suits, right? Okay. Okay. Okay, great. Then we have a set that will have all the elements, right? Multi-set. We need to insert every element into it, right? Okay, that's what you already said. Now, upper bound. It's more than one. Now I have num. Upper bound is an iterator, right? Here we are upper bound. You know, 42 is, and for the 36, अप टू 3 जा सकते हैं, 3 या 3 से छोटा खोजना है। फिर पहला नंबर मिले, अच्छा दैट इज अ गुड थिंग। 3 या 3 से छोटा नंबर। Then target equals to k. Okay, k. Now k divided k should be subtracted with num. Plus what, right? This is the target which you want to match or lower bound. समझ में? Find a q that is less than equal to target. X3 में पता चल जाएगा. Now okay, एक ऑटो आइटरेटर लेते हैं. ऑटो ये बताएगा कि लोअर बाउंड, ठीक है, ms डॉट बिगिन डॉट एंड, ठीक है, ऐसे नहीं होता. This is the syntax. it equals to ms dot target value. Okay, this is wrong. target value, ठीक है, यहाँ पे रहेगा ms dot. Okay, now this will give me the exact tg और tg से just छोटा. Okay, if it not equals to ms dot and that means कि कुछ मिला है, तो कुछ मिला है, then वो एक ऑपरेशन होगा काउंट प्लस प्लस. ओके, ऑपरेशन होगा काउंट प्लस प्लस and we need to remove this thing. ms dot ओके, ठीक है, ओके, Okay, I think this works. This count print करना है. This is not needed. Sorting is not needed. We can do this directly ऊपर में, but ठीक है. Let's try it. If this works, this will be a great solve. Please work. 022 and we needed 103. Not right. 022 127. Okay. So where is the check and other stuff, right? Okay, num plus 1. Now we found a number that is equal to target. That means this target will be around 3. That we will multiply it with if x equals to, you know what is y, so we know the value of the iterator. We need to, if x is less than equal to k, then only we do this. Okay. Zero, 1, 2. This is what do we say? Um, um, what do I say? I want 1, 0, and 2. I'm getting a very different set of. Okay. Say Okay, let's print the stuff, right? Print the stuff. This will be a big of log n, and we have n going on, so n log n. So we want y, okay? We want the multiplication sign, we want the value of the iterator, we want the plus sign, we want num, and just new line. Let's print it. Okay, so for this thing we'll have one operation. Say we are 27. 27 plus 1 is 28, right? 28. 28. This is 28. Now if y more than equals to k, then it's not more than equals to k. Okay. The target is k, that is 100 minus 28. 100 minus 28, that is 72 by 28. I have 2, so 2 या 2 से नीचे I want something to be found. In MS, oh, it doesn't get you a lower number, right? What we can do is कि oh, I got it. Yeah, same या उससे बड़ा number ढूंढ रहा है. Lower bound doesn't do that, right? Okay, upper bound does that. Okay. Mm-hmm. No, the facts are not correct. Okay. There's a way around it. Upper bound will give me an iterator that is strictly greater than the target, and the iterator just before is the desired iterator can be equal to tg or just less than tg. So that is good ना. तो मतलब अपर बाउंड अगर एंड तक दिखा रहा है, कभी भी एंड तक नहीं दिखाएगा. इट विल गिव मी अ नंबर दैट इज ऑलवेज प्रेजेंट. नहीं, strictly finds for a greater number, right? If it's showing to the end, it tries to find strictly something that is greater than n. That means उसके पीछे जो भी है, it's strictly smaller than or equal to, right? तो begin नहीं होना चाहिए. begin होगा तो -1 नहीं कर पाएंगे, तो desired हो जाएगा हम लोग का required iterator equals to it -1. ठीक है. Now अगर begin है तो you cannot do anything, you have to skip it. And we can check this out. This works. ms.begin अगर हो जाए तो we cannot go back beyond it, so we can skip that and that won't be valid. It should work. Let's see. -1. Okay. If I have an IT, how do I get the previous iterator? IT -1. You can get the previous element bidirectional access. Okay. Okay. इसका नाम prep रख देते हैं, that will be a good thing, and we just do the prep. Hope it works. You cannot subtract from the beginning, it will go out of bound, and it's 100% sure that upper bound will not give me ms.end because it will, if everything is smaller than target, then if even if it gives ms.end, even if it gives ms.end, we can just do the minus and get the first thing that's there. The multi-side is sorted, I believe. So 102. Okay, this is in a good direction. 28, 27, that's a great thing. 10 into 2 plus 9. Okay. Couldn't do. Just skipped all of stuff from there. Now I did with 10. It is 9. Okay, so do you think R needs to be sorted? Go to 2, 1. 8, 9, 8, 8, 9. Did one with 9. Out 2. do you think it ended? Outside of it, say these two are good. Okay, say we are fine with the result of the previous two and we want to check what's happening. All the iterations of y into, you're not getting any press yet. Stream is already over 3 hours. We started with 10, we got a 10. We went with 8 and we got into it. Then we had 10, 9 again, then 8 again, and 100 couldn't cut it through. Okay, let's go. I understand. It's aboving all occurrences of 2. Is removing all element that is similar to 2 or yeah. Now I think this will work. These work. Yes. प्रीवियस वन क्या हो रहा था कि आइटरेटर देने से आइटरेटर हटाएगा, नंबर देने से ऑल ऑकरेंसेस ऑफ द नंबर हटा देगा. तो या ग्रेट, इट्स वर्किंग. ये सब हटाते हैं. Okay, let me do something. This works and login में हो रहा है. Yeah, learned about multisets because using multiset was new for me. Between middle removals, use a multiset. Now I know why use this multiset. I always thought that what is the need of multi-set, because we had set which stored unique, but multi-set are storing duplicates, which defeats the purpose of set. So what is the need of this multi-set? Now I know, because it helps frequent updation and deletion in the middle in login. It has useful functions like upper bound and lower bound, but I'm getting a lower wrong answer. In this case 2. Second number, the first expected one from 0. Okay, edge case. This one edge case test नहीं किया. Say I have 1 and 3, and 1 plus 1 is 2, and 21 is 2, this one is 3, is equal to 3. Why? Because did I skip it anyway? The last one comes here. EG is, target is K, that is 3, minus Y, that is 2. What we are trying to find is, we have 3 and we subtract 2 from it. Now we subtract maybe subtracting 1 from and divided by whatever space for num. So if we 2 minus num is 1, 2 by y, that is 1. You have K, okay. You have K, that is 3. Now we want Y, our Y, that is 2. 2, give me an quotient that can Hmm. So we need to find तो जो भी ये मिले now just last ठीक है these are the input टारगेट ऐसे 100 है now we have 27 right so say it was we wanted a remainder of 19 ठीक है and it was 100 okay then अगर remainder 90 जाए तो your diffuser should be 20 so diffuser is 20 now y ठीक है now 2 into 1 यहाँ पे 2 into 1 plus 1 so 2 plus 1 is 3 तो काउंट का वैल्यू तो इंक्रीज हुआ है वन होना चाहिए it was count is in यहाँ पे total was a code log for myself. So man, count 0 है, and this value is 3, right? अंदर आया, काउंट को तो बढ़ाएगा। कहीं पे हम के को तो बदल नहीं दिया ना। इसके अंदर नहीं घुस रहा क्या? ठीक है, प्रॉब्लम क्या है? Can this thing be 0? ये अगर 1 हो जाए, नहीं, x is 4. Oh. ओहो, ब्रैकेट्स की वजह से। जो छोटा फ्रैक्शन हुआ, how x can be 4? multiplication sign and all. Adding it. फॉर्मूला ही गलत लिख दिए थे. I think this will work. Let's submit it. It's like MF wrote the most efficient code of his life. Yeah, got accepted. ये तो सब बना दिया है. Great feeling. So it's great. Took me around 100 minutes and plus 10 minutes to debug. So it's a 110 minutes to hour 50. Almost 3 hours took me. Almost 2 hours, no? 120. 1 hour 50 minutes. Great. So that was great. That's it for today. See you in the next one.